Alright, so I've had an opportunity to play with this pedal for a little while, and I wanted to make some observations that's going to kind of guide us as we move forward with this prototype. So, first of all, the distortion is very touch sensitive. I can definitely tell that it's different than a solid-state diode-based distortion pedal, and I'm really thrilled with the touch sensitivity and the tone. So I want to keep that. Second, I do have a ground loop problem. When I plugged into one of my combo amps, I didn't have hardly any noise, but then when I plugged it into kind of a different area, into a different amp, I had a lot of noise. And so I need to fix the ground loop problem, and I've got an idea for that. Next, I need to change the way the tone control and the bass switch are working. I felt like they were just a little bit mild. Like with the treble control all the way down, wasn't really bleeding off as much treble as I was hoping it would. And the bass switch is also pretty mild. I think I want something that's a little bit more aggressive. So I got some ideas on that. And then I just forgot to add my effect on-off indicator light. I got the power on or off light on the top, and I'm glad that I have that. But I also want to add an indicator light when the pedal is active or inactive. Okay, so regarding the ground problem, what I need to add is a ground lift type of situation. I explained it a little bit in my previous video, but in case you were having a hard time understanding, let's see if we can find an image to look at. Okay, so here at the IEC jack, we've got an IEC power cable that's plugged into the wall, providing 120 volts of AC. The middle lug is grounded to the chassis, so the chassis has a ground path through that middle lug out to the wall. But then the output jack is going to run a guitar cable. The exterior sleeve of the output jack is also connected to the chassis, so there's a second path for ground to flow current. So those have the opportunity to form a ground loop. Now there's a couple things that we can do. First of all, I've got you can isolate these jacks by using a washer that has a little shoulder on it. So you need to drill the hole out just a tiny bit bigger, and then use a jack isolation washer that puts a little shoulder underneath it. Second option is you could use a cliff jack, which would have made out of plastic. It would not actually ground the shield or the sleeve to the chassis. So I got some of those on order. They're coming in the mail. But then second, I'm also going to implement this ground lift switch. This is from Merlin Blenco's Valve Wizard's grounding PDF. This is like the Bible about grounding. You should really read it. It's excellent. But it does some nice explanations here, and it's got this little ground lift circuit. And I do plan on implementing this ground lift switch. It's a hum block network. So I believe that what's happening here is, even if I do isolate the jacks, it's still possible I might have some kind of ground loop just with things interacting, different devices interacting with each other. And so I'm going to implement this ground loop. And I'm optimistic that between adding this ground loop and isolating the jacks, that I should be able to get rid of all those problems with the ground noise. Then let's talk a little bit about the changes to the circuit, so the tone controls. Now, this is a second revision that I added, and I had kind of my sizzle control, which really was kind of inspired by a Tweed 5F2A Princeton here in the middle, and I've taken that out, and I think one of the issues is having a treble control that's located here in the middle of the circuit was maybe causing some problems. And so this is kind of tone stack location design principles. See, what's happening is this first gain stage is amplifying the signal like a loud clean boost. And when you crank the gain control up, it's basically all running into V1B. And then this tube is the one that's responsible for generating the overdrive and distortion. Well, overdrive and distortion is known as harmonic distortion, meaning it's going to be generating upper end harmonics. So even if you do some treble roll-off here in the middle, because you're pushing this tube into harmonic distortion, a lot of those harmonics are still being generated, even if the input signal is a little bit duller. So I'm going to place the treble control, just a simple treble roll-off pot here at the end, right after the coupling cap, but before the resistor and the 25K level pot. Then I may also experiment with, instead of this cathode bypass cap switch, I want to put it on a pot, and so I added a bass pot here in between the gain stages, and my thought here is this will help trim a little bit of bass, but also can help tighten things for the distortion. So I think that it should work. Now, this was taken from Rob Robinette's voicing web page on how to voice a tube amp. And the way I've got this, I have a 1 meg audio pot, but that means that if I wire it this way, as you turn the pot up, you're going to be cutting bass. So it's more of like a thin pot is how I might think about it. But that's the pot I've got. So it means as I turn the bass pot up, I will be cutting or trimming bass. If you turn the bass pot down, you're going to be adding a lot of bass. Then the treble control will work the opposite way. So if you turn the treble pot up, it'll get brighter. If you turn it to the left, it'll turn darker. So my bass and treble controls, if I was going to do it again, I probably would switch to get an anti-logarithmic pot and flip the wiper actually goes to terminal 3 instead of 1. But honestly, that doesn't bother me. If I was going to like try to sell this pedal or make it for another person, I would not do these things. But if it's for my own personal use, I want the functionality. I don't care how the knobs, if they turn left or right at this point. So I'm going to move forward with this design. So I think these design changes should make this thing a lot better. So let's give that a shot. Okay, this was a little bit crude, but I have implemented in this area the hum busting circuit network circuit from Merlin Blendco's website. I just went through it on the schematic review, and essentially what's going on here is all of my grounds, my circuit grounds, come to this green wire to right here, and then they run. So this point right here on my terminal strip is my universal grabs ground spot. Then I have a capacitor on the bottom there underneath that red thing. I've got this resistor. This is a 10 watt 50 ohms, which is, it's a little bit overkill in terms of wattage and a little high in resistance, but I think it's going to work fine. I think Merlin called for like a 3 watt 10 ohm, but I think it's going to be fine. And then those are bridging over, and then these two lugs of the terminal strip are grounded to the chassis. And then I've got the diode network right in here. So we've got basically a cap, a resistor, and a bridge rectifier from the circuit ground to the actual chassis ground. So that's how I've implemented that ground circuit here. It's a little bit annoying because it blocks a lot of these circuits underneath, but to be honest, this thing's getting to a place where, I mean, I could still work on it. Like, you could unscrew this and get underneath it, but the ease of access has gotten a little bit trickier, and I'm learning a lot as I'm going through this kind of build for the first time. But yeah, I think the combination of both this and the upgrade to the plastic cliff jacks will help eliminate the noise. Alright, this is a crude documentation, but my buzz is still there. More on that later. But I changed my tone pot. I went from a 1 meg and a .0047 cap to a 100K and a .002 cap. And so with it on maximum, this is what it sounds like. And if I could just document it before, with the first iteration, the tone control, like when I went from like 8 out of 10 to 10 out of 10, it had a huge jump in volume and brightness, and then it just reacted really weirdly the rest of the way down, and like from 5 to 0 it was kind of unusable. Now, this is my tone control now, so it's all the way off. And this is all the way up. So that's definitely a lot better. I do want it to be darker when it's all the way to the minimum, so I'm going to keep experimenting with the values, probably of the capacitor. Alright, this is an online tone stack calculator. There's your website if you want to check it out. Now, what I'm most interested in, I've got this RT here. That's my tone pot at 100K. Then my capacitor currently has 2.2 nanofarads. If I make it all the way down, I want it to be darker. So I want this line to move this way. So if I increase my capacitor, you can see that line is moving down. So if I go up to something maybe even like 10 nanofarads, that should, and then if we sweep it at full up, we still have maybe a little bit of attenuation at 10K, so that might be too much. Let's try like 6 nanofarads. That looks pretty good to me. And then here, compared to where we're at now, which I think was 2 nanofarads. Yeah, okay. So I want to increase the value of my capacitor to make it darker on the minimum. All right, here we are. Finally had some parts come in the mail, so I'm ready to move forward with a couple little tweaks. Order of business. First of all, I've got some plastic cliff jacks. Hopefully that's going to cure my hum loop. Second, I've got some LED mounting components here. So we're going to replace the LED, make that a little bit more sturdy. And thirdly, on my IEC input, I made a mistake with my wiring diagram, so thank you to those who pointed it out. With the IEC jack, you've got the center lug here is the ground. Now, the way I'm looking at it here, the ground lug is down. So then one is the hot, one is the neutral. The way I've got it right now, this one on the left is going into the power transformer. And then one here on the right is going into the switch and the fuse. Well, we need to flip that around. The hot wire needs to go into the switch and the fuse, and the neutral wire can go into the transformer. The way it's set right now, the voltage is always going into the transformer instead of running into the switch first and foremost. So we need to send the voltage, the hot lug, into the switch first. So we're going to flip those around. Okay, let's talk through these jacks a little bit. This is the old one I've got. You can see this part right here. This is the sleeve. So the shaft of your 1/4-inch jack is going to come in through here. It's going to make contact with this point right here. But you can see all this metal stuff also is connected to the sleeve. Or when you install the 1/4-inch jack into the chassis by screwing it in, then the sleeve gets grounded to the chassis. Now this is the plastic cliff jack, and you can see here the inside. So this is the metal screw. This metal screw goes into the plastic housing, and then you've just got 2 points of contact here and here. The rest of the body is made out of plastic. So when you insert a jack, the tip goes here to the edge, the sleeve goes here to the middle, and you've got 2 possible connection points for each spot. Piece of cake. But there should be no, by installing these in here, there should be no grounding of the cliff jack just by installing it. Now what that does mean is I do have to install ground wires, which are going to run here to this universal tab. And I still have my ground hum buster eliminator circuit in there. But everything else should be good to go. I flipped my hot and my neutral. I got my new, more permanent LED installed. and I've got my cliff jacks. So let's give this bad boy a shot. Oh, last point of comment before I do that. This is what I'm working with. I got an Electro Harmonics 12AX7EH, which actually I think sounds really good so far. So let's button it up and test it out. All right, I want to do a little bit of tweaking of the tone stack. I want to show you guys a little bit of what I'm experiencing. I've got it plugged in. I'm actually running DI, so I'm running a cable into the pedal. I'm running the pedal into an audio interface, then I'm using an amp simulator in my computer. So really, it's just a very clean amp. Sounds like this. So for starters, with the bass switch, this is the tight mode. If I go up, it's full bass. So to my ear, that's trimming frequencies kind of in the 100 to 150 hertz range. Now the way I use the pedal, I pretty much am always using the bass cut mode. I just find that full frequency mode to be a little bit too fuzzy and woolly and woofy. So maybe at some point I'd be curious to maybe tweak those values a little bit. I'm not sure yet, but I'm happy with how the bass switch works. Now let's talk about the tone control. Again, this is just a treble roll-off control. So I hear just a little bit of change from like 0 to about like 10 o'clock. I mean, it changes a little, but not a ton. At the 12 o'clock position, it's dark. And then really from noon until 2 o'clock is when it kind of opens up. With the treble all the way up, I wouldn't say it's overly bright, but maybe a little bit. I guess I would say overall, it feels like I'm mostly living between noon and full. So I'd be kind of curious to see if I can change the values of the bass and the tone to make them a little more usable. I guess I just feel like the tone control in particular, from noon to off, it doesn't feel super usable to me. So I'd be curious to tweak with that a little bit. And this is a follow-up to the tone control stuff. First of all, on the bass switch, it goes between a 10 microfarad cap for the full frequency, and then the tight switch is a 104 capacitor code, which comes out to a 0.1 microfarad cap. So I wonder if maybe I would consider reducing both of those. Maybe take the 10 microfarads down to like 1 microfarad, and then the tight one, you could maybe think about cutting it in half to like a 0.047. That would make the tight mode even tighter, and then the full frequency mode would be kind of somewhere in between. Next, I just want to check and confirm what I actually have for the tone control, because I was messing around with some different things and kind of plugging stuff in, but I want to actually measure it in circuit. So I know I've got a 100K audio taper pot, and then the caps are coming back here at 33 nanofarads. So yeah, I'll have to play with that a little bit to figure out how to shift it maybe a little bit darker, question mark? All right, I wanted to pause here and just walk through just a brief bit of the schematic that I'm at. This thing has been in constant revision, and actually I'm really enjoying this process of tweaking it to my heart's content. But for my bass control, that's right here, and it's on this first preamp stage, and I like toning down a little bit of the bass early in the circuit. I find that it really changes how the pedal feels, as opposed to later in the circuit, then it's just more of a straight EQ change. But by keeping the tone bass switch here, I can really tighten the feel and the response. So by cutting out some bass early, going between this 0.1 microfarad cap, cathode bypass cap, and the 10 microfarad cap, the 0.1 being the tight, the 10 being the full frequency, I've got a lot of nice options there. You could also mess with these decoupling caps, or there's also a 10 microfarad cap here, but again, I really am enjoying the way I'm tightening the bass up here on the beginning input of the circuit. Helps keep it tight all the way through. Then the tone pod back here, actually this is incorrect. This is currently at 4.7 nanofarad. Again, what I was experiencing with 100K, and actually I had like about 30 nanofarads at first, was I just wasn't getting a ton of effective range. And by the time you got down to 50%, it was already like exceedingly dark. So I wanted more of an effective range, so I cut this down. That means that the sweep of the tone pod is more usable, and it starts to, it basically has more brightness throughout the higher range, and at 50% it's brighter than where it was at before. So I'm certain that I will continue to mess around with this thing, maybe even have follow-up videos, but I do want to dive into one of the most exciting steps in my opinion, which is to take this thing, get some Velcro on it, and sticking it on my pedal board. Let's dive into that. All right, I hope you guys enjoyed that video. This is my third part. I'm very confident I'm probably going to have more parts, but for now, I want to at least kind of give a little bit of encapsulating thoughts on where I'm at, how we got here, and how I feel about this pedal. So first and foremost, this is probably about as much fun as a nerd can have over the winter months here in the Midwest where it's really cold and snowy. This has been a terribly fun and exciting project. I've really enjoyed working on it, and I would love to continue to iterate on it and make it a little bit better and a little bit better. The experience of playing with this pedal now at this stage is really satisfying. It's a tube amp in a pedal. All the things that people use to describe overdrive pedals, solid-state overdrive pedals using transistors or op amps or diodes or whatever. I mean, none of that really applies here because this literally is a tube amp in your pedal. And so all of those tube characteristics, right? It's creamy, it's fuzzy, it's spongy, it's got all that just really delicious tube character. It overdrives in such an organic manner. It really feels like an extension of your tube amp because that's what it is. There's no impersonating. There's no circuitry, trickery. It literally is just a couple extra tube gain stages running at full high voltage, just as if you are running a multi-channel tube amp. And so I find that to be really, really exciting. Yet on the flip side, I have the flexibility of putting it on a pedal board and using it in a variety of situations, and that's just very exciting. The pedal is definitely more of a medium gain pedal, meaning it doesn't get extremely saturated on the high end. However, one of the clips at the end, I actually put a boost pedal in front of it and was really impressed at how well it responded to that boost pedal. Because then you're basically driving and cascading both of your gain stages instead of just one of them. And so then you can really push this thing, the way I would think about it is if you've got like a plexi, at a gain stage, you get a JCM 800. At another gain stage, then you start to get into like Soldano or Mesa territory. That's kind of what you have here. Or if you want to talk about on the Fender side, right? You've got your regular Fender amp, like a Vibroverb or something. Add a couple of gain stages, then you get into like a Dumble territory. That's kind of what we're doing is we're taking my clean Fender sound, moving it up into kind of the Dumble area. And so, putting a solid state boost in front of it, just slamming the level, the output level into that first V1A gain stage was really, really satisfying and something I'd really like to explore in the future, maybe even considering adding a second foot switch that adds a solid state boost into the front end, kind of a more switch, so you have that ability to use it both as a medium gain like it currently is, or as more of a medium to high gain pedal. So I'm really enjoying that. Second, I really, really enjoyed the tweaking with the tone stack, and I think I've gotten both of them to a nice spot. I would say overall the EQ is on the warmer side, meaning it's tough to get it to sound really shrill and bright, just with the way I have it configured now, and I might iterate on that in the future. I'd be curious to try more of maybe instead of a bass switch, trying a bass pot. But I'd be a little bit concerned once we start adding a pot in there, you're adding some series resistance to the signal. That's going to change the way that the impedance works in between some of those early gain stages, and it might result in some insertion loss, and I don't really want to take away gain. So I might have to do those in combination, where I have the bass pot in combination with the level or the more switch on the front end, so then they kind of balance each other out. But the last comment I want to make too is, this thing is hilarious because of how big it is. So I'm gonna see long term how well it works on my pedal board, because this thing is a monstrosity. It is massive, and so it does kind of throw the spacing off a little bit on my pedal board, but that's okay. I think I can work with that a little bit, and still I think it'll be a ton of fun. And I really haven't even tried some of the use cases of this. One thing you really could explore is running this into an audio interface, using it as a preamp with an impulse response. I'd be really curious to see how that sounds, and would love to do a video like that someday. So again, for now, I'm really thrilled with this thing. I'd love to hear your guys' comments down below. Again, some of the things I'm thinking about in the future are adding that more switch to the front end, changing maybe adding a bass pot. And one of the thing I've been thinking about is I also drew up this schematic in Eagle, so I have the ability to actually try to put this thing onto a PCB. And if you guys are curious about that, I would be willing to dive into that a little bit more, maybe order some PCBs, do a little bit of fine-tuning, and maybe get to the point where I could offer them for sale. If you'd like to build one of these your own, but you don't want to do it point to point like me, you want to do it on a PCB, that might be a doable project. So if you're curious about that, leave a comment. But I got to quit for now. I'm sure I'll have more on this thing in the future because I'm really excited about it. So love to hear your comments down in the comment section below. We'll see you guys again soon. Thanks. Bye.